Well, hello Internet, and welcome to part 4 of my C video tutorial. Today we're going to do a lot of experimenting using pointers and how they relate to arrays and functions. And if you missed any of the previous parts of this tutorial, I provide a link to all of those in the upper right hand corner. And I'm also going to try to transcribe what I'm saying here in this tutorial, and I'm going to provide it in the code that is in the description for this video. So I have a lot to do, so let's get into it. Okay, I'm using the same setup as before, Text Wrangler, Basic Text Editor, and Terminal. If you're on Windows, use Notepad++ and the command line, or whatever you want to use. Okay, so I'm going to be doing a lot of experimenting here because I want to try to make this fun, and I'm exploring different teaching capabilities that I have. Now, of course, we all know whenever we compile and run our program, you're going to be provided with a piece of memory and RAM to store the data, for example, like variables. So let's just come in here and just create ourselves some variables. ran2 is equal to 15. Okay, so we know that that is going to be assigned to some area inside of the memory. And each time we're going to create one of these integers, 4 bytes of data is going to be saved in that memory. And we know that because of the previous tutorials. And each of those areas in memory are going to have an address, which we are going to be able to use to locate said data. And we can actually come in here and return said address. Let's just say ran1 is equal to, by putting in a %p, and then we'll say ran2 is equal to, and another %p, like that. And then what we're going to have to do is throw an ampersand in front of those two variables. So there's ran1 and ran2. That's going to return the addresses for them. Now, sometimes it's going to seem as if these variables are actually going to be stored next to each other, but that's not necessarily true. The reason why people think it's true is very often they are stored next to each other, but not always, so you can't really rely on that. So, for example, just to show this, type in a D, and then what I'm going to do is put size of, and then throw rand1 inside of there, which is going to pop back a 4. Then if I want to go in here and actually print this out, rather than using the hexadecimal version of the address, I want to print out the decimal version so we can analyze this. I'm just going to put in a D inside of there. Don't need to change anything else. Pop over here, compile and execute. And you're going to see here, there's the hexadecimal version of the addresses, and here is the decimal versions of exactly the same address. See here, the size of the integer is 4, and you're going to see here 88. Well, if we go 89, 90, 91, 92, there you're going to see the new address for the next one. Very often, like I said, they show up next to each other in memory, but not a good idea to count on that. Now, if we want to assign this address to another variable so that we can pass the address along to, say, maybe other functions so that they'll be able to access the data, we're going to have to use the same exact data type for our pointer, and very often pointers are going to be having a P in front of them, and then we just get the address exactly the same way that we got it before. And there we go. And now it is going to be stored inside of this variable, the address that is. And just like we did previously, we're going to be able to go in here and print out the address for our pointer. So let's just change this to pointer, like that. Pointer again. And the only thing that's going to be different is this actually has the address inside of it. So we don't need the ampersand in that situation. We can just type in random1, or actually it's rand1, and then rand1 again. Up over here, compile, execute, and you're going to see that, yes indeed, this address that is down here, 756, is the same as the one that's up here. So that's how we can store those addresses inside of other variables. Now, if we want to actually go in here and get the data that is held in that address using the pointer, we're going to use an asterisk to get the value that's stored there. And this is known as dereferencing the pointer. And dereferencing just means to use the pointer to access the variable. And it's very easy to use. We're just going to say printf. And if we want to say value for the pointer, we want to get the decimal representation since it's an integer, of course, that's going to be stored in there data-wise. Then we're just going to put the asterisk inside of there, and then p rand1, just like we did before. Compile, execute. And you can see now the value is 12. And if we come back upside here, well, I didn't actually print the value out, but we can come up here and see that rand1's value is 12. So that's how we can get that information. So now let's see exactly how we're going to work with arrays and pointers. Now, in essence, an array name is pretty much a pointer. So we're going to create prime numbers like this, throw some data inside of here, and we can actually print the values by index, just like any other array. So if we say first index like that, we can then come in and go prime numbers and print the index that way. But another way we can use it, or another way we can print it, is using the asterisk, because what is passed over is, in essence, a pointer, and by putting an asterisk in front of it, that is going to give us the first index inside of our character array. Compile and execute, and you can see they are the same. Now, of course, we're going to be able to very easily get the 3, for example, by just coming in here and changing this to 1, but how would we do the same exact thing down here using this asterisk? Well, we're going to use something called pointer arithmetic to access that information, and in essence, what you're going to be doing is adding 1 to the address. And since it contains ints, in essence, what's going on is we're going to skip 4 bytes forward. And yes, if you were wondering, you're able to also do this and grab information that lies after the memory area where you are, but that's not advisable. And there we go. That does exactly the same thing. Compile, and there you can see. So that's another way to get in here and do this stuff. Well, that brings us to how do we work with arrays of strings? Well, in essence, what we're going to do is we are going to create an array of strings by creating an array of pointers. And to do that, we're going to type in character with an asterisk, students, and let's say we want to hold 4 of them. And let's say it's Sally, Mark, Paul, and Sue, just random names. And there we are. Now, if we want to retrieve them, we could do it in a bunch of different ways. And that's kind of why I'm approaching this as experimenting with this stuff. I think it's a little bit more fun, but it's also going to show you the importance of experimenting. Okay, so if we want to print out this information, and let's say that we want to print out more than just the name. Well, to get the string, I mean, it's a string, so there we are, just put a yes inside of it. But if we also want to get the address for it, just put a D inside of it, bounce down here, and then we're going to say students, I, and then we can get the address by putting the ampersand in front of it and doing students, I as well. Compile, execute, and there you can see not only the names print out, but also the addresses. That's kind of cool. So now let's go and take a look at how we're going to use pointers with functions and how to pass information back and forth between functions. We're going to basically do the same thing again. We're going to create rand1. This time I'm just going to initialize it to 0 and rand2 and initialize that to 0 as well. Then what we're going to do is we're going to mess up on purpose here first, just to show how important pointers are. And I'm trying to present this multiple different ways to use pointers. And as the C tutorial itself continues, I'm going to change some things. Alright, so we have that set up, and of course we're going to create our function ahead of time. Up here we're going to say void, might as well just go and copy this, generate 2 random numbers. And that's why we need standard library, by the way, is we're going to use a random number generator. Int rand1. Remember, it doesn't matter what the name is, these are brand new variables, and just the values of these are being passed up here. So the name really doesn't matter, but I just wanted to use the real name just to show that. Okay, so now if I want to actually come in here and generate some random numbers, I'm going to use the rand function. This isn't the greatest random number generator, but I'm just using it just here for now. What this is going to do in essence is generate numbers from 0 to 49. Of course, if you want to generate from 1 to 50, just add a 1 to the end of it. Come up here, change this to random2, and then let's say I want to come in and actually print out new rand1 in function is equal to, and go rand1, and then we can do the same exact thing for rand2 just to show that it's not working the way that we might have thought it would too. Then we can come down inside of here and go print rand1 is equal to, and print out exactly what rand1 is equal to, and then do exactly the same thing for rand2. Compile and execute, and you can see up here in the function they were generated and they got number 8 and 50 for the random number. However, down here inside of main, rand1 and rand2 still have the value of 0. So how do we fix that? Well, I think you know the answer is going to be pointers. But you may ask yourself, hey, what about global variables? Remember last time we used global variables and we were able to access those global variables and change them no matter what function we were using? Well, that's actually a pretty good idea, except for the numerous problems that come along with global variables. So for example, just to list a couple of them. Let's say you have all your variables stored as global variables. Well, if you bring in any other outside functions, you might have problems such as naming conflicts. You use the same global variable, same name as somebody else uses, so that could cause a lot of problems. It also can be really hard to figure out where changes are coming from whenever so many different functions are accessing global variables. And it's also going to eliminate a lot of flexibility because you don't know if a change made by one function might adversely affect some other function in your program. So it's best to almost never use global variables. And like I said before, we're going to be able to solve all these problems using pointers. So let's come in here, and I'm just going to change the code a little bit, and we'll say printf, and then we're going to say main before function call, because I probably should have did that before. Let's clear this. And then we're going to call function, and then I'm going to say main after function call, and then I'm going to print these out like that. And then I'm just going to change the name of this so I don't cause confusion. I'm going to say pointer random numbers, and in this situation I want to pass the address. How do I do that? What am I going to put here? Ampersand, of course. And I'm going to put another ampersand. That's going to provide me with the address so that I'm going to be able to go in there and change it. And then I'm going to come in here, copy that, paste that in there, and then I have to come up here and create pointer random numbers. So I'm just going to leave this right here the way it is. There's one change here I'm going to have to make. I'm going to have to put a star inside of there. And if your arguments that you're sending to a function are ever passed as pointers, you're going to put this asterisk after the data type in both situations, of course. And just to reiterate, because I keep bouncing back and forth between the ampersand and the asterisk, to get the address of the variable, we're going to use the ampersand, that guy right there. And to access the data that's in the address, we're going to use the asterisk. Okay, so that's how it's different. Then if we want to assign, we're just going to put a star in front of here, star inside of here. And then if you want to retrieve the value also inside of the function, you're going to put another asterisk inside of there. Compile, execute. You can see main before function call. Rand is 1, 0, rand 2 is 0. New rand 1 in function is going to be 8 and 50. We're back inside of main, and rand 1 still has a value of 8 and 50 that was assigned in the function. So you may ask yourself, well, how do you pass strings around? Because that's one of the only things we didn't cover. Let's just get rid of that altogether. And let's get rid of this method here altogether. And let's do pretty much the same thing with main. Okay, so what we're going to do is we are going to create a character array. I'm just going to call it random message. And I'm going to say edit my function. There we are. So there's a couple different ways to do this. I'm going to do it treating it like it is an array, because that is what it is. Alright, so what we're going to do here is we're going to pass in random message, and then we're also going to pass in size of random message to our function. And then of course we are going to print it out, printf, and say new message like this, and random message after the function's all done. So that just leaves us to create edit message sent. And what I'm going to do with this is go void edit message sent. Then what you need to do is go character star for the message, and I'm going to just have it be a different message name. It doesn't really matter. And then I'm also going to come in here and go size, and I'm going to create a new message. Like I said, I'm going to treat this like an array because that's what it is. And we're going to go new message. Then I'm going to say if the size you passed in is bigger than the message I'm about ready to put inside of there, well, that's okay then. And I'm going to say int and define this. I don't have to do that. I can just go for int I is equal to 0. Doesn't really matter. Then I'm going to say I, while I is less than size of new message, and then increment I. And then if I want to assign these new values, I can do so. New message. And then I could come down here and say something like else new message is too big, or something like that. Compile, execute, and you can see that new message was overwritten based off of the previous message. And just to prove that, I guess I didn't prove it, type in old message, file save, compile, there you go. Edit my function. I should have typed in edit my message, doesn't matter. Edit my function, and there it is as new message. So that's one way to change or edit strings inside of outside functions using pointers. As the tutorial continues, I'm going to try to experiment more and have these tutorials be a little bit more fun and maybe make them feel a little bit more like a classroom atmosphere. So of course, if you have any questions or comments, leave them in the comment section below. Otherwise, till next time,